Good morning, functions class. All right, we are going to start solving right triangles. So I covered this in class yesterday, which was May 5th, Cinco de Mayo. All right, so we are going to go ahead and get this in your notes. Let's see if I can get this going. Hold on, let me hit pause. Okay, so remember when we were starting this unit and I said that the notation in this unit is going to be really important. So the notation in this unit is really important. One of the things is when we're looking at drawing a triangle, you always want to start labeling the triangle with the things that you know, and you're going to know what the different things are because the capital letters are going to be the angles and the lowercase are going to be the side measurements. You always want to start your triangle with that given information. Make sure that you put things where they belong, so you're always going to put that right angle is going to be capital letter C, and the hypotenuse, which is going to be the opposite side of that angle, is always going to be lowercase c. So you really want to make sure that you get those set up correctly. So what we're going to do now is we're going to kind of talk about how to set that up. Let's see. There we go. So to solve a triangle, it means to find all of the measures of all of the angles and all of the sides. So when we're setting up our triangle, again, this is something that I just talked about, but I would go ahead and get this example of a triangle set up correctly. Typically, you know in class that I will write it oriented the other way, where I have, here, I'll draw a little picture of it right here. I usually write my triangles like this, because that's in standard position. So it doesn't actually matter. So I can make this one match exactly. And then remember, A is going to be the opposite. So I'm going to finish on B. And then B, side B will be the opposite of B. Okay, so you can draw either way. It doesn't actually matter. But what matters is how you label it. And make sure that you label it correctly. So again, just as a quick reminder that the letter C is reserved for the hypotenuse. And that is mostly to tie in that Pythagorean theorem, because we're going to use that to find any missing sides. And if we remember that C is always the hypotenuse and that the Pythagorean equals the hypotenuse squared, then it'll just kind of help keep things together. Again, as you go forward in math and go higher in math, you'll use different letters, probably X, Y, and R, or other letters, but it just doesn't matter. Knowing how to set it up is what matters. Oops. So let's look at this example. So we're going to solve triangle ABC, and it's a right triangle, so we're given some information right away. We have at least one angle given to us, the right angle, so we know what kind of triangle we're going to be dealing with. And then if A is equal to 34.5 degrees, then C is going to be equal to 12.7 inches. So go ahead and set up your triangle and hit pause and do that. So my triangle is set up this way. Again, I orient it this way. And I was given this angle, angle A. I was also given angle C. So, and then I was given the hypotenuse because it says C is equal to 12.7 inches. So now what we're going to do is we're going to start taking the information that we know. So I am given angle A, so we're going to use the sine of this angle to find the other side lengths and ratios, because we can't use the Pythagorean theorem. I can do A squared plus B squared equals 12.7, and then I'm still stuck. I can't eliminate anything. I still have two variables. So what I'm going to do is I'm going to use sine. And the reason why I'm going to use sine is because sine is the first one that comes up, but it also has the hypotenuse in it. It's the opposite over hypotenuse. So what I'm going to do is use the sine of A is going to be equal to my opposite over hypotenuse. But I actually know what A is, and I know what my hypotenuse is. So I'm going to plug those two things in. And once I plug those two things in, I can start solving for an unknown. So the sine of 34.5 degrees, this is just a number. This is a number, this is a decimal number. So what I'm going to do is I am going to multiply both sides by 12.7, because that'll get rid of that, but then I've got to put it over here. If I do that on one side, I've got to do it to the other. So there I've multiplied, and I want everyone to type that in their calculator. So now that I have A is going to be equal to whatever 12.7 times the sine of 34.5 degrees. Now, if you didn't get 7.19 inches on your calculator, then your calculator is set to the wrong mode. What you need to do is you need to go into mode on your calculator, You're going to type mode. You're going to scroll down 1, 2, and then you're going to go over where it says radian and then highlight degrees. So to the right, you'll go down to radian, go to the right to degrees, hit enter, and then second mode again. And then try that problem again and you'll get it. All right, so now because we want to use the given information before we move on to anything else, we are going to use something else. So if I know, so now we know this is equal to 7.19 inches. So now I still have an unknown. This is something I found. It wasn't given, but I have a hypotenuse. And I know that if I can find the cosine, the adjacent over the hypotenuse, I'm still using all my given information. So I am going to use the cosine of A, which is the adjacent over hypotenuse, and I'm going to plug in the parts that I know. I know that the angle A is 34.5, so I'm going to put that in right here. I also know what my hypotenuse is. And again, I'm going to multiply both sides by that 12.7 to eliminate that, and then I have it on this side. So again, we want to plug that in our calculator. I think I've messed up my animations on here, so it's not going to tell us what it is, but it is equal to 10.5 inches if you plug that in your calculator. Okay, so now we know what this is, so we're going to say equals 10.5 inches. We still need to find angle B. So we know that this is 90 degrees. So what do these two angles have to add up to? Well, they have to add up to 90. So we also know that we can take 90 degrees and subtract this one, and we will get this angle. So if we take 90 minus A and we plug in the parts that we know, so 90 minus 34.5, there's the 10.5, told you it was out of order. So then we end up with B is equal to 55.5. So this is 55. So now we have found, every degrees, there we go, every part of that triangle. We know all the parts. You can actually do the Pythagorean theorem, and if you plug all of this in, you'll get really close to 12.7 inches. And then you can go the other way and find B and try to solve for the unknowns, and you'll get about the same. So we could have found the measurement of angle B first and then use that trigonometric function of B to find all the unknown sides. We could have done that, and that probably would have been okay. It doesn't actually matter which direction you go, but you should always, to maintain the most amount of accuracy, just to make sure you didn't make a mistake, type something in wrong, wrote something down wrong. Like I've been grading your log test, and I've seen that you guys have missed your pluses and minuses from the actual problem. So the mistakes do happen. So to ensure that as many mistakes or as few mistakes are done, just use the given information first. As you go further in math, using the given is always going to be where you want to start. You always want to start with what you're given. You always want to start with what do you know. And that's going to actually help you with the word problems that we'll be doing tomorrow and the following day. So that will help you. If you guys have any questions, just send me an email or ask in class. Otherwise, I hope you have a great day, and I'll see you later today.